today we are going to learn about refraction and dispersion by prism. Before going into detail of this topic, we will see what we have learned in the refraction by glass slab. In refraction by glass slab, we have seen that the opposite faces of a glass slab. By opposite faces, I mean the face where the ray of light is incident and the face from which the ray of light emerges out. So in a glass slab, the opposite sides or the opposite faces are parallel, and for this reason, the incident ray and the emergent ray are found to be parallel. We will now discuss refraction through an object where opposite faces are not parallel. A triangular glass prism is such an object where opposite sides are not parallel. It consists of two triangular surfaces and three rectangular surfaces. One of the rectangular surface is known as the base of the prism, and the other two rectangular surfaces are known as the refracting surfaces. This is because the light is incident and emerges out of any of the refracting surfaces. The angle between these two refracting surfaces is known as angle of the prism. For an equilateral triangular prism, the angle of prism is 60 degrees. The line along which the two refracting surfaces meet is known as refracting edge of the prism, and any section perpendicular to this refracting edge is known as principal section. Here, as you can see, this is refracting edge and this becomes the principal section. Now let us see the phenomena of refraction through a prism and how refraction of light through a prism is different than refraction through a glass slab. Consider a ray of light from a laser incident on one of the refracting surfaces. Let's say that the incident ray is PQ. Now let us assume that there is a normal NN dash at point of incidence Q and the angle made by the incident ray PQ with normal is I. I is known as angle of incidence. Since the ray of light is traveling from air, that is the outer medium, that is to the glass prism, it is traveling from optically rarer to denser medium. So you can expect that the ray of light is moving towards the normal. So as you can see that QR becomes the refracted ray and the angle made by the refracted ray with the normal is R, where R is the angle of refraction. Now, if you consider a glass slab, you can say when it will emerge out, it will be parallel. But here, the opposite faces are not parallel, and so we cannot expect that to happen. So, let's say that RS is the emergent ray. Now here, as you can see that it is traveling from glass prism to air, so it moves away from the normal because it is going from optically denser to optically rarer medium. Let's say that the angle made by this emergent ray RS with the normal at the point of emergence R is E, where MM dash is the normal. Angle E is known as angle of emergence. You can see that the incident ray and the emergent ray are nowhere parallel. And you can say the emergent ray gets deviated. So, if you extend the incident ray and you can see that you can find the angle of deviation. So what is angle of deviation? Angle of deviation is the angle made by the emergent ray with the direction of incident ray. It just says how much has the glass prism deviated the incident ray of light. So you got to know that in a prism, the opposite faces are not parallel, and so the incident ray and the emergent ray are not parallel. So this was about refraction of light by prism. Now we will talk about dispersion by prism. But before going to dispersion, we have to talk about some of the phenomena that we see around us. So it is very beautiful to see a rainbow, right? But have you ever thought from where does the 7 colors are produced? And have you ever thought that if you observe the tube light through a plastic ruler, you can see the same 7 colors? In fact, the same 7 colors are seen in soap bubbles also. So have you ever thought from where are the seven colors produced? Actually, the seven colors are produced by refraction of sunlight or tube light. The sunlight is actually a white light and it is a mixture of seven colors. Sunlight is the most important natural source of white light. Besides this, the light from tube light is also white light and it is a mixture of the seven colors. And when this white light gets refracted, it splits out into its constituent colors. Newton experimented and found that these seven colors can be refracted and formed on the screen by a prism. For this, he took a bulb as you can see here which is emitting white light, and there is a circular plate with hole from which the narrow beam of this white light comes out. When this narrow beam of white light is incident on one of the refracting surfaces, the constituent colors of light change the medium, and since all have different speed of light, they get deviated and travel differently. This broad patch of seven colors is obtained on the screen. The seven colors of this patch are red, orange, yellow, green, blue, indigo, and violet. The seven colors are also denoted by the word Vibgyor, which is a shortcut for the seven colors. That is Vibgyor, which if you give the full form with each letter, then V for violet, I for indigo, B for blue, G for green, Y for yellow, O for orange, and R for red. So this is for Vibgyor. Here, since red has the maximum speed in glass, deviates the least and comes out, whereas violet with the minimum speed in glass deviates the maximum and comes out. Now, you may ask, can we recombine all this color to form white light? The answer is yes. Actually, we can do this with an experiment of Newton's disk. Newton's disk is a circular disk which is divided into segments of seven colors. When you rotate the disk with a very high speed, we can get an illusion that the disk is white because of the combination of seven colors. So we think that the disk has become white. This is just because of the combination of seven colors. Newton showed that these seven colors can again recombine to form white light using prism. So let us see what he experimented. He kept another prism near to the first prism in an inverted position. When the dispersion of white light into seven colors takes place from the first prism, it is incident on the second prism, on the refracting surface of the second prism, and these seven colors recombine to form white light which is formed on the screen. So this is how Newton experimented and found that the seven colors recombine to form white light, and this he experimented using prism. This phenomenon of dispersion of white light is responsible for formation of one of the most beautiful example of spectrum, that is rainbow. Rainbow is an arc of seven colors from top, that is red, to bottom, that is violet. If you are lucky enough, you will find there is another rainbow above this prominently seen rainbow, which is known as secondary rainbow. So as you can see here, we have two rainbows. The first one, that is known as the primary rainbow, and the other one that is known as the secondary rainbow. In primary rainbow, the red is at the top and the violet is at the bottom. Whereas in a secondary rainbow, red is at the bottom and violet is at the top. For the formation of rainbow, it is necessary that sun is shining and it is raining at the same time. If you want to see a rainbow, your back should face the sun and you should be in front of the rain. So this is the condition to observe a rainbow, that the sun should be back of us and it should be raining in front of us. To understand the formation of rainbow, it is first important to learn the refraction of light through the tiny water droplets, because rainbow is formed by dispersion of white light by tiny water droplets which act like a small prism. So we will not go into detail of formation of rainbow, but we will see what happens to the path of light inside a raindrop. So for a raindrop which is in the formation of primary rainbow, The ray of light first gets refracted and dispersed into 7 colors, and if these 7 colors are incident at the critical angle of the raindrop, then they get totally internally reflected and gets again refracted when it emerges out. Whereas in the formation of secondary rainbow, the sunlight gets refracted and dispersed into 7 colors and gets totally internally reflected twice and again gets refracted and dispersed when it emerges out. Now, so primary rainbow is a three-step process, that is refraction, total internal refraction and refraction. Whereas secondary rainbow is a four-step process, that is refraction, total internal reflection, again total internal refraction and refraction. And this is for this reason that for a primary rainbow, the red color is at the top and violet color is at the bottom. Whereas for secondary rainbow, violet color is at the top and red color is in the bottom. Due to two total internal reflections, the secondary rainbow is fainter than the primary rainbow. You will study in detail about this formation of rainbow in the higher grades, and you will also see that are really rainbows bow in shape. You can also explore more on the topic of rainbow, and you can also go to the play with the object for this and you can think of it. So this was about dispersion of white light and diffraction of light by a prism. In the next topic, we will study about scattering.